Okay. So we all know about fake news. We see it. People probably send it to you. And we all know that's pretty much an issue. It's a big issue. And research shows that it's created by low credibility sources, and it's spread mostly by unwitting humans, not bots. And obviously, this is something that we don't want around. So social platforms, when they want to deal with fake news, they have a few different ways that they've been all converging on. The first being by algorithms, so just keyword identification, blacklists, machine learning, a bunch of other stuff. Or they'll use a group of average users to do the actual fact-checking itself. And research shows that when you use a group of average users, you get a similar accuracy to when you go ahead and hire professional fact-checkers, which is also something social platforms do. But social platforms, obviously, all the content is in the clear. So all these tools then rely on the content being in the clear itself too. So what about end-to-end encrypted messaging systems? How do we solve detecting and moderating fake news in these systems? Well, obviously, Signal, WhatsApp, and Telegram, you don't have access to the content when you are the platform. So the platform can't just hire fact-checkers to fact-check content on Signal, because Signal can't see the content by design. So how can these platforms deal with fake news? Well, we've seen some tools come out for just dealing with moderation in general for these platforms, such as forward limiting, message franking, searchable encryption, which is similar to blacklists on social platforms, private set intersection, which is similar to keywords and private machine learning. But these tools can sometimes fail to cover the nuance of fake news itself. So for example, the first few words on this list obviously will almost only be in fake news all the time. But words like CIA, I might just be talking about the CIA because I passed the CIA building. So I don't want my messages revealed in Signal or whatever these platforms are just because I said the word CIA. And that's just an example for keywords why it might fail to get the nuance, but in general, we see that a lot. So we thought, okay, maybe we want to design a tool specifically for fake news and moderating it. So let's define fake news a little bit more. We went with content that is seen by many users or viral, but many users can discern as false. So given that definition of fake news, what do we really want then? Well, we want to crowdsource the detection of fake news. So like we were saying, a large group of average users can detect fake news with a pretty good accuracy. So if we want to detect fake news, one of our options is simply crowdsourcing it. And if users decide to identify something as fake news, well, and there's a lot of them, well, that's probably a pretty good indication that it is fake news. Another goal was just to maintain privacy and security. Because if we're using Signal, we don't want to give up more privacy and security for moderation because we're using Signal in the first place. Some non-goals is to set in stone what specific content should be moderated. So beyond saying we want to moderate fake news and identify fake news, we don't want to say anything more. We don't want to say, oh, this is fake news, that is fake news, beyond that, the fact that an average group of users has considered it and identified it as fake news. We also don't want to say what should happen to the fate of accounts. What should be the fate of accounts in content when it's actually detected or identified as fake news? We decided to punt that and just leave it up to the platforms or to other people to decide how you actually moderate and go about removing fake news and dealing with that. But the important part is no matter how you deal with fake news, you probably either need the content or who actually originated it. And so that's what we want to do. We wanted to identify the originator and the content after a crowd has decided it's fake news. So there's some current approaches to this. The first is creating an encrypted path of forwarded messages. This is a previous paper at CCS. And the way this worked is they created just a path of all the forwarded messages, and when someone complained about it, that whole path was revealed. And so the issue with this is it kind of defeats the whole purpose of, okay, we want to identify fake news, because now one single person can go and reveal everything. And so even if it's just a message I sent to a few people and they forwarded it and it's about like brunch or some secret documents, a single person can now reveal everyone who's received that message. And maybe for fake news, we probably don't want to do that unless it's a lot of people reporting it. So that brings us to our solution, facts. As far as setting goes, we're just going to make a few assumptions, like the messaging system is centralized like Signal or Telegram. We're going to assume all messages are original or forwarded, and that complaints are rare relative to number of messages sent. So everyone on this platform will only complain about things when they actually feel like it, not every single thing they receive. As far as actors go, we're going to have the server, who's just, we're going to assume is semi-honest. We're going to assume most users are also semi-honest, and only a few of them are malicious and are the ones spreading fake news or helping to spread fake news. So as far as facts goes, the benefits this system gets us is that users can actually send and forward messages like normal, which is obviously a necessary part. They can complain about messages, and they can start audits when complaints have reached a threshold. As far as the server goes, their role in facts is going to be transmitting messages, moderating reported content or the originator, storing complaint information obliviously, and recovering the originator upon the audit when it's initiated. So as far as security goes, we want to make sure that users should not be able to complain about a message they haven't received. They shouldn't be able to manipulate the number of complaints for a message by a significant amount, and they shouldn't be able to falsify the message originator. As far as privacy goes, we want to maintain end-to-end encrypted privacy, and we want to make sure that the user and server should not be able to see what users are complaining about or complain about a message that they haven't received. So the way we actually made sure we could do this is with a data structure called collaborative counting Bloom filter, which is an oblivious multi-counting data structure. What this allows us is to obliviously count when people have reported a message. So say someone forwards a message to a bunch of people, all these green circles sees, hey, look at, I'm getting this bad message and it's fake news, and they can report it obliviously, and then after a certain threshold is reached, well, now that user originator is moderated somehow and hopefully removed from the system or something like that. And this obviously achieves the previously mentioned goals. So our first attempt for this was just to use a count min sketch, basically meaning that the server maintains a table of counts, each message is assigned to some set of slots, and the slots are only known to the users. If you want to complain, all you do is you increment all slots of the message, and then to count the number of complaints, you take the minimum to find the current number of complaints. The messages being these fruit emojis. The problem, though, is that the complaining patterns are revealed. So if I go and report on the orange emoji message and someone else does, well, now we're incrementing all the same slots, and so the chance that we're reporting the same message and that that's obvious to the server is super high, and the server almost certainly will be able to tell. And that's something we want to hide, because we don't want the server knowing that two people are complaining about the same message. So how do we fix this? Well, instead of having multiple slots per message, each one all being incremented, what we did is we said, for each message, you're still going to get a set of slots, but each slot can only be 1 bit, meaning if I go and report a message, then someone else goes and reports a message, we're incrementing different slots, and so that access pattern is hidden. So you can't tell between two users if they're reporting on the same message. And then as far as the threshold goes, you end up deriving that from the sum of slots per message. As far as complaining goes, literally like I was saying, you just flip a bit. And so now there's no overlap, and so there's no revelation about who's complaining about the same messages. But how do we actually get those slots for the message? Well, this is where the origination protocol comes in. And essentially, all that happens is when someone creates a new message that they're going to then send or forward to a bunch of people, they will just hash the message and then bind their own unique ID to that message and have the server will sign it. So essentially what happens then is whenever you receive a message, you can double check that, yes, this encrypted originator ID, which the server encrypted, goes along with this message, but you can't actually read what the originator is because it's encrypted. So there's another problem with this system, though, is that a malicious user might receive a message, and they might just go ahead and say, oh, the orange message, strawberry message, let me just set all the bits to 1. And so I can just go ahead and report this message basically a bunch of times, which defeats the whole purpose of having a threshold if one user can trigger an audit. And so obviously we don't want that because that defeats the whole purpose. So how do we solve that? Well, just like the messages, we decided to assign the users a subset of the slots also that they can report on. Meaning, on average, each user will have an overlap with a message set of slots, like so with 1 or 2 slots per message. So that way a user can basically only complain about a message once, maybe twice. And what that means is if you go and complain somewhere outside of your set of slots, the server will say, hey, you're not allowed to complain there. I don't know what you're complaining about, but you shouldn't be complaining there, that's for sure. That's not your slots. And so the server can say, don't do that. I'm not going to accept this. And what this allows is that now users can only complain once or twice per message. And so we're back to having that threshold, meaning that so many users have to actually report a message before an audit begins, which is good. So as far as what this looks like in practice, well, the dog might report a message, the avocado message, and then the cat reports the orange message, and then the cat goes ahead and reports the avocado message again and says, hey, look at all these slots that I'm looking at. Well, all these slots are 1, and this is for the avocado message. So given this approximation, we've probably reached that threshold. And so that user, since they're obviously reporting a message, they want it reported, they'll go and tell the server, hey, this message has reached this threshold, and the server itself will then receive both the message and the encrypted originator ID from that reporting user and do whatever they need to do to moderate that user, because they now know who the originator is and what the message is. So as far as count estimation goes, there's still a little bit of a problem, because like we said, well, all these messages slots and all these user slots are now overlapping to hide the actual access patterns, right? But what that means now is I might report one message, and that might also be a slot for a different message. So you can't just necessarily go ahead and assume that all the bits, the sum of all the bits is what the actual number of reports are. So we had to come up with some sort of approximation to approximate the true number of complaints from the number of bits set, given all the different variables when you create that table. And as far as our approximation goes, it turns out it's pretty good. And so on average, we have a pretty good accuracy that once the number of complaints for a message actually gets the number of bits set, gets to a certain number, we can say, hey, that's pretty close to the threshold, and that actually is going to trigger an audit. And even with a high number of background complaints, meaning complaints about other messages, not necessarily this one message we're looking at, even with a high number of them, that threshold that we reach to trigger an audit is still very close to the explicit threshold that we set. And that's for a good number of different types of background complaints and different numbers of thresholds. As far as issues go with this system, well, malicious users could share messages with each other. So you could have a group of 100 different people that you decide to collude with, and you say, I don't like this true news, I'm going to report it as fake news, and you could send it to all of them, and they could go and report it themselves. But we decided this is an issue that we didn't want to tackle, since we consider it to be relating more to how do you make sure that real people are honest and have accounts, and you can't just make a bunch of bot accounts. Because frankly, if your platform has like 90% bots, then most people probably aren't using it, hopefully, and that's a totally different problem altogether. Another issue is that the server sees that a user has complained about something, not that they see what the user actually complained about, but the server can't see, yes, you did complain about something. And in a perfect world, the server wouldn't see that, but that's not something we achieved with this system. And finally, this only identifies the originator, not users spreading it widely. So even though you might be able to detect these sources of fake news, there might be these 2 or 3 people that always are sending fake news to everyone they know, and maybe the platform wants to detect that too, because that might be useful to know. But this system doesn't do that. Finally, there's a performance issue where, since everyone is sharing this one Bloom filter type data structure between all the users, well, if you're all reporting something at the same time, the server needs to manage that and sync that. And so theoretically, depending on your implementation, that could create a performance issue, but that's more of an implementation detail. But that's fighting fake news in encrypted messaging systems. Thank you for listening.